Hello, viewers. Welcome to the lecture series of SSC Quantitative Aptitude. This is your tutor Keshwa Agarwal, and this is lecture on time and work. So, in this lecture, we are going to study multiple variable based questions. And second section, we will study traditional method for finding the time. And in the third section, we will study finding the time to complete a work by three men. And in the fourth section, we will see LCM method for finding the time. And in the fifth section, we will study relation between time and efficiency. And at last, we will see some questions based on time and work. So let us start with the very first part of this lecture, that is multiple variable based questions. So let if M1 men can finish a piece of work in D1 days, working H1 hours in a day, and efficiency of them is E1 and unit of work is W1, and M2 men can finish a piece of work in D2 days and working hours H2, efficiency of them is E2 and unit of work is W2. Then we can define a relation here that says M1 times of D1 times of H1 times of E1 upon W1 is equal to M2 times of D2 times of H2 times of E2 upon W2. So let us have a look over an example. So we have 5 men which can complete a work in 10 days, working 6 hours in a day. In how many days 8 men can complete the same work working 4 hours in each day? So using the relation that we have seen in the last slide, M1 D1 equal to M2 D2 H2. So we have 5 times of 10 times of 6 equal to 8 times of D2 times of 4. So when you simplify this, you will get 75 upon 8 days. So 8 men will do the same work in 75 upon 8 days when they work 4 hours each day. Another example, 36 men can do a piece of work in 8 days if they work 6 hours per day. If find the number of days in which 24 men can do half work if they work 8 hours per day. So let here information given is M1 equal to 36, D1 equal to 8, H1 equals 6 and work is 1. M2 equal to 24 in the second case, D2 is unknown, H2 is 8 and we want half work, so that W2 will be 1 by 2. And now the relation that we studied was M1 D1 H1 upon W1 equal to M2 D2 H2 upon W2. That means 30 times of 8 times of 6 upon 1 equal to 24 times of D2 times of 8 upon 1 upon 2. And when you simplify this, you will get 9 upon 2. That means 4.5 days. Now let us move ahead and see traditional method for finding the time. If A can complete a work in n days, then A's 1 day work is 1 upon n. And if A can complete a work in m days, while B can complete the same work in n days, then work done by A in a day is 1 upon m, and work done by B in a day is 1 upon n. So that work done by A and B in a day will be 1 upon m plus 1 upon n, that is equal to m plus n upon mn. So let us see example. If A can complete a work in 4 days, while B can complete the same work in 6 days, in how many days both of them can complete the work? So work done by A in a day will be 1 upon 4. Work done by B in a day will be 1 upon 6. So the work done by both of them will be sum here, 1 upon 4 plus 1 upon 6, that is 5 upon 12. Therefore, the time taken by A and B together to finish the work will be 12 upon 5 days. Now, let us see the third section of this lecture, that is finding the time to complete a work by 3 men. If A can complete a work in M days and B can complete the same work in N days and C can complete the same work in P days, then the total time taken by A, B and C together to complete the work is given by 1 upon M plus 1 upon N plus 1 upon P, and when you simplify this you will have MNP upon MN plus NP plus PM. So this is your formula that is useful. Let us see an example. If A can complete a work in 4 days, B can complete the same work in 6 days, and C can complete the same work in 8 days. In how many days all of them can complete the same work? So we are going to use the formula that we have seen in the previous slide, that is MNP upon MN plus NP plus PM, that is equal to 4 times 6 times 8 upon 4 into 6 plus 6 into 8 plus 8 into 4, that is 24 upon 13 days. Now, LCM method for finding the time. So the LCM of time will give you total work, and 1 day efficiency into time will give you total work. So these are the two formula, and don't worry, we will see examples on these and how to use them. So A can finish a piece of work in 6 days, B can do the same work in 8 days, while C can complete the same work in 12 days. In how many days they can complete the same work? So A can complete the 6 in 6 days, B can complete in 8 days, and C can complete in 12 days. And as discussed, you have to take the LCM here, take the LCM of all these days, that is 48. Okay, and the work efficiency will be obtained. Divide 48 by 6. So you will get 8. Divide 48 by 8, then you will get 6. And divide 48 by 12, you will get 4. And you want the amount of when they three work together. Okay, so A plus B plus C will be 18 here when you take the sum of this. So 48 was the LCM and 18 is the sum of 1 day work efficiency. So 48 upon 18, that is 8 upon 3 days, is the final answer. Hence they complete the work in 8 by 3 days. Relation between time and efficiency. So the comparison of rate of work done is called efficiency of doing a work. So we can write it mathematically as efficiency is inversely proportional to number of days. So higher is the number of days, lower is the efficiency, and lower is the number of days required to complete the work, higher is the efficiency. So let us see an example. Three persons can complete the work in 4 days, 6 days, and 8 days, respectively. Find the ratio of their efficiency. So the time taken by them is in the ratio 4 is to 6 is to 8, and we want efficiency of ratio. We can just do the reciprocal as seen in the previous slide. So it will be 1 upon 4 is to 1 upon 6 is to 1 upon 8. But nobody likes fraction, so we have to get rid of fraction. So to do that, take LCM of denominators, that is 468, and it will be 24. So multiply this ratio by 24, you will get the efficiency ratio equal to 6 is to 4 is to 3. Now we are done with the theoretical part, and we are ready to solve questions. So let's start with the very first question. If A can complete a work in 6 days, while B can complete the same work in 9 days, in how many days both of them can complete the same work? So there are two people, A and B, and A can do this work in 6 days while the B can complete same work in 9 days. So we are interested in finding when both of them work together, how much time will be required. So the solution. So the time taken by A is 6, which is given in the question. Time taken by B is 9, that is also given in the question. So as discussed, you have to just take the LCM of time taken by A and B, that is 6 and 9. So it will be LCM equal to 18. And now check 1 day work efficiency, that is 6 divide 6. So divide 18 by 6, you will get 3, and divide 18 by 9, you will get 2. So the 1 day work efficiency, total 1 day work efficiency of A and B is equal to 5. So the final answer will be 18 upon 5 days. That is LCM upon 1 day work efficiency of both of them. So the option correct here is option B. Now, question number 2. Worker A takes 8 hours to do a job and worker B takes 10 hours to do a job. How long should it take both A and B working together to do the same job? So time required by A is 8 hours, time taken by the B is 10 hours. Take the LCM of 8 and 10, you will get LCM equal to 40. And now next thing we want to find is 1 day work efficiency. So divide 40 by 8, you will get 5, and divide 40 by 10, you will get 4. So these are the work efficiency of A and B respectively. So the total work efficiency of A and B will be 9. You have to just take the sum of 5 and 4. So the time taken by A and B while they are working together will be 40 upon 9, that is 40 upon 9 days. So the option correct here is option A. Let us now see question number 3. A and B can together complete a piece of work in 4 days. If A alone can complete the same work in 12 days, in how many days can B alone complete that work? So again, here we have A can complete in 12 days. So the time taken by A will be 12, and it is also given that together both of them complete the same work in 4 days. So A plus B is equal to 4. That is also given to us. So the LCM of 12 and 4 is 12. Okay. And 1 day work efficiency of A is 12 divided by 12, that is 1. And the total work efficiency will be 12 divided by 4, that is 3. So we have work efficiency of AB together is 3 and A alone is 1. That means the work efficiency of B is going to be 3 minus 1, that is 2. All right. So the time taken by B alone to complete the same work will be 12 upon 2, that is 6 days. So the option correct here is option C. Now let us move to question number 4. If A alone can do a job in 36 days, then how many days can B alone do the job if together they do the job in 24 days? So time taken by A is 36 days and together time taken is 24. So take the LCM of A and B, A that is 36 days and 24, that will be 72. Now the work efficiency. So work efficiency of A is 72 divided by 36, that is 2, and the work efficiency together is 72 divided by 24, that is 3. So since the together work efficiency is 3 and work efficiency of A alone is 2, that means the work efficiency is 3 is going to be 3 minus 2, that is 1. So time taken by B alone to do that work will be 72 upon 1, that is 72 days. So the option correct here is option C. Now moving on to question number 5. A can paint a house in 55 days and B can do it in 66 days. Along with C, They did the job in 12 days only. In how many days C alone can do the same job? Let us now have a look over the solution. So A takes 55 days, B takes 66 days, and together they take 12 days. ABC together takes 12 days. So take the LCM of 55, 66, and 12, and the LCM is going to be 660. Okay. So the work efficiency, 1 day work efficiency of A is going to be 660 divided by 55, that will be 12. 1 day work efficiency of B is going to be 660 divided by 66, that is 10. And the total, when they work together, their work efficiency is 660 divided by 12, that is 55. So we know that work efficiency, 1 day work efficiency of combined all of the three together, and it is equal to 55. So if I take the difference, if I subtract the work efficiency of A and B from the total work efficiency, I will be left with work efficiency of C only. So it will be 55 minus 12 minus 10, that is 55 minus 12, and it will be equal to 33. So now time taken by C, if he did the work alone of painting house, it will be 660 divided by 33, that is equal to 20 days. So the option correct here is option B. Question number 6. Working together, A and B can do a job in 18 days. B and C can do it in 24 days, and C and A can do it in 36 days. In how many days they can complete the same work? So it is given that A and B together do it in 18 days, B and C together can do it in 24 days, and C and A together can do it in 36 days. So if you take the LCM again, 18, 24, and 36, it is going to be 72. And now, what is the work efficiency? 1 day work efficiency of A and B, it is 72 divided by 18, that is 4. 1 day work efficiency of B and C together is 72 divided by 24, that is 3. And 1 day work efficiency of C and A together is 72 divided by 36, that is 2. So the total work efficiency will be A plus B plus B plus C plus C plus A, that is twice of A plus B plus C equal to 9. So the 1 day work efficiency of A plus B plus C is 9 by 2. So the total time taken by A plus B plus C will be 72 divided by 9 upon 2, and it is equal to 16 days. So the option correct here is option D. Let us now move to question number 7. A and B can together complete a piece of work in 8 days, and B and C together can do it in 12 days. All of three together can complete the work in 6 days. In how many days A and C together can complete the work? So again, we have A plus B equal to 8, B plus C equal to 12, and A plus B plus C is equal to 6. So we have to just take the LCM of 8, 12, and 6. It will be 24. Okay. So 1 day work efficiency of A and B is 3, that is 24 divided by 8. 1 day work efficiency of B and C together is 2, and 1 day work efficiency of A, B, C together is 8. Okay. So we can take the difference, 8 minus 2 minus 3, it will be 3. So the 1 day work efficiency of C plus A is 3. So C plus A is equal to 24 by 3, that is 8 days. So if C and A had to do this task together, they will take 8 days. Question number 8. A can do 50% of the job in 16 days. B can do 1/4 of the job in 24 days. In how many days can they do 3/4 of the job while working together? So in this question, A can do a job, 50%, half of the job in 16 days, and B can do one fourth of that same job in 24 days. So we have to find when A and B both work together, how many days will be taken by them to complete three-fourth of the job. We are not interested in finding the complete job, but only the three-fourth of the job. So A solution, A can do 50% of the job in 16 days. Therefore, A can do 100% of the job in 32 days. Similarly, B can do one fourth of the job in 24 days. Therefore, B can complete the job in 96 days. So half information about some portion of the work was given, but I used it to find how much time will they take to complete the complete job. If they have to complete the job, how much time will be taken by them? So A takes 32 days while B takes 96 days. So just take the LCM of 32 and 96, you will get 96. So the work efficiency of A is 96 divided by 32, that is 3, and 96 divided by 96, that is 1, is the work efficiency of B. So when they work together, their work efficiency will be 4. So A plus B is equal to 96 upon 4, that is 24 days. That means if A and B have to do the work together, it will be completed in 24 days. But we are not interested in how much time will they take to complete the full job. But we need three-fourth of the job. That is, three-fourth of the job is equal to 96 into three-fourth, that is 72 units. And time to complete three-fourth of the job will be 72 upon 4, that is equal to 18 days. So the option correct here is option D. Now, let us move to question number 9. Prabhat has done half of the job in 12 days. Santosh completed the rest of the job in 6 days. In how many days can they together do the job? So this question is very much similar to the previous one. So Prabhat has done half of the job in 12 days. Therefore, Prabhat has done complete job in 24 days. Okay. Santosh has done remaining half job in 6 days. Therefore, the Santosh can complete the job in 12 days. That means, so 20A is equal to 24, B equal to 12. If you take the LCM, you will get 48. So the 1 day work efficiency of A is 48 divided by 24, that is 2. And 1 day work efficiency of B is 48 divided by 12, that is 4. So the total work efficiency is 6. 2 plus 4 equal to 6. So when they do it together, they will take 48 by 6, that is 8 days. So the option correct here is option C. Now the last question of this lecture. A can do a work in 36 days and B can do it in 32 days. If they work on it together for 12 days, then what fraction of the work is left? So this is a very interesting question. In this question, they are not asking how much time will be required to complete the work when they do it together. Rather, it says A can do it in 36 days, B can do it in 32 days. And we made them work together and it's been 12 days till now. So, how much fraction, what fraction of work is still remaining? So, that's what we have to find. So, A equal to 36, B equal to 32. So the LCM of 36 and 32 will be 288. So 1 day work efficiency of A is 288 divided by 36, that is 8. 1 day work efficiency of B is 288 divided by 32, that is 9. So the total work efficiency, 1 day work efficiency of A and B together is 17. So the work done by A plus B in 1 day is 17. Therefore, work done by A and B in 12 days will be 17 into 12, that is equal to 204. And the remaining work is equal to 288 minus 204, that is equal to 84. So the fraction of work left is equal to 84 upon 288, that is 7 upon 24. Hence the option correct here is option A. So that would be all for this lecture, and I recommend you to solve these questions by your own without having a look over the solution. And I'll see you in the next class with more questions on time and work.